Alright, we're day 19, but Errol's been working while we've been gone. On the wiring loom, ooh, look at this. All the electronics, the brains are plugged in.
Yeah, although we're still a bit, I mean, obviously it's still pretty rough. However, we are now doing functional testing. So you want to see that all your equipment is actually working. Yep. Biggest thing is that your Garmin equipment, that the comms between all the different parts of a Garmin is working well. So what we've got here is we've got obviously the two GDU 460s, which is your two displays. Then you've got the Garmin G5 at the top there. And then right down here, this is your navigator, that's the GNX 375. Now that is the certified GPS unit, a WAS certified GPS unit, but it's also a transponder unit that will give you ADSB in and out, which means you will be able to display traffic on your two displays there. Then you've got your GAT27, which is basically your flap and your trim and light controller. So your wig-wag lights, that's coming from there. Your instrument panel dimmings can come from there. Your flaps and your trim motor are being controlled from that unit there. Then down here you've got your GAT29. Now that is what we call an A-ring converter. It converts the A-ring high-speed signal from the GNX 375 in terms of traffic data so that it's readable for that unit. You've got your GEA24, this is your engine monitor. So this engine monitor will communicate through these two connectors, which is your HIC connectors to your Rotax engine. So when you plug that into your Rotax engine connectors, that unit will be able to display all your engine information in your display there. So that's your big interconnect. So which means once your instrument panel is all done, you can disconnect these three connectors. This goes to the bottom and to the top of the aircraft. So this is, see this as bottom and top of airframe, and from that side there, that is an instrument panel.
Is this big board mount to the roof?
Yeah, we stick it down with a couple of screws. Yeah.
Hey, what's this thing over here, by the way? The black.
Oh, that is your GSU 25. That's your ADAS. So the ADAS is your attitude sensor. So pitch and roll will pick up pitch and roll. And then right at the end, normally in the tail, is this little unit that sits there. That's the GMU 11. And this little unit here is your compass. That's your compass sensor. Okay, so that's your little electronic compass. Now then you see these two big boys here. That is your autopilot servos, GSA 28.
Which is which, just out of curiosity?
So one will be a pitch, one will be a roll. One will sit in top where your aileron sits, and this one will sit in the back where your pitch sits. Okay. So that's the whole. So then your light controller, so this is basically just roughly, this is your light controller. You'll have wig-wag or taxi or off. You'll have a landing light, a nav light, a strobe light. Then you've got some circuit breakers up there and your ventilation. I still need the switch here. This is basically your ventilation control. One will be heat and one will be open and close for pilot and one will be open and close for co-pilot. So this little unit sits right on the top there. And then we will have some wiring running from here down this line. You can see there's one already. That's one of the lights that goes to the tail, runs all there and right back to the tail of the aircraft. So switching it on. I hope it still works. So yeah.
Power.
Let's just
clear prop.
Get some. Yep. Prop. Get some power on there. It should all start up.
Oh, look at this. Wow. Screens are alive. Wow.
But it's always for us, it's like almost when you fit your engine, it feels like a bit of a milestone.
It sure does.
And then when you switch this on and there's no smoke anywhere, that's a bit of a milestone. So just continue. So you can see it still has the Americas chart in there. So basically what we will do Just continue. So you've got the standby radio, and you've got the panel mount radio, you've got the GNX 375, and then you've got your panel mount intercom system. So at this point in time, everything is selected there. We can just switch all of that off. But yeah, so that's that. Yeah, so pretty, huh?
Very nice.
That's there you can see it's all still somewhere in America, Kansas City.
Yeah.
So that's the standard database, but obviously once we start programming it here, we get the avionics guys out to come and certify everything. Then we will obviously upload the database for Australasia.
Where's the third pilot?
So the third pilot?
Yeah, the push button pilot.
Oh, the push button pilot. The autopilot is the GMC 507. Where is it? Hanging out there. Oh, there. And that is the third pilot. There you go. So yeah.
Get to work.
And yeah, so all of that is good. Everything is communicating.
Wow.
So that's good. Yeah.
It's very exciting.
So it's getting real.
How's it feel, Bruce?
It was pretty good.
Yeah.
Looks pretty good.
It sure does.
So the plan is today I'm just finishing off the final little connectors that goes into the aircraft. So use these Deutsch connectors instead of the big Canon connectors.
They're good connectors.
They're pretty good. They seal very well. We use them in automotive.
Yeah.
So I want to try to finish off the switch panel. So it'll be a lot of wires here, and so that we can get all the wiring out to the lights in the wings, down to the tail, right to the back. We will do these connectors that goes to the back of the aircraft, so that's all done and dusted. And then we will start pulling in probably tomorrow, maybe today already, start pulling in this harness into the aircraft, start fitting it inside the aircraft. And if all goes well, by Friday, I want dash in, test panel in, not the real panel still will be cut, but just a test panel in with wiring so that we have everything literally where it should go. So we are still waiting for the little avionics panel from the factory where these ones will be fitted. That's a bit of a pain right now.
That little
but once
tray
we've
in
got
the
that-
center console? The little tray that goes in the center console?
Yeah, it's in the center console there, so yeah, a little bit of a weight there on that. But apart from that, pretty much on track here.
It's fantastic.
Yeah. Starting to look the part. As I say, still very rough. We haven't really not neatened up anything. Now we can start neatening up the whole loom and,
Do you wrap it in insulation or?
You can. You know the car tape?
Yep.
Some people like to put it in the car tape, and it may not be a bad idea. We can do it, but you really want to make sure that your system is ready
Before
you start doing that. But yes, so we can get some of that car tape and just roll it, especially where it goes into the tube that goes to the top, so that you don't have any shaving on it.
Right.
Apart from that, some people wrap it in like that expandable snake skin or whatever they call that.
Common tubing.
Yes, the problem with that is it's quite a story to feed every piece of wire. Imagine from there to there, and then from there to there, and so I just don't do it. So wrap it, or just make sure that when you install it, it's absolutely not shaving on anything. Do regular standoffs, and it's.
How do you test the autopilot servos to see if they're actually
On the
functioning?
first flight. No. You obviously do proper ground testing.
Okay.
Generally speaking, when the system can actually see the autopilot, it means it's communicating to the autopilot, which means it's literally just a matter of just calibrating the autopilot. And the autopilot, you basically just calibrate it for the amount of force it will exert on the stick. So you can go from about 50% to 100% force. So the force required to undo the clutch. So it will resist up to a point, and then it should disengage automatically.
Okay.
So That's for one thing, and then just the severity. I don't know what's it called. There's a name for it, but the severity of the change. So how quick or how slow it reacts to changes. So you don't want the aircraft to go like that, but you also don't want it to start this type of a loop. So you want a nice, fast enough, but not uncomfortable.
Right, okay.
So that's setups that we do while we're flying. But you obviously do a full ground check where you can physically test it, and the servos will physically move from one to another side. You actually teach the servo where's the end stops of your movement, and that feedback is obviously given via a sensor in here, which is just a variable resistor, but it will tell that system exactly where that arm is at any time. So yeah.
But there's no way to test these just to see if they're actually connecting and operating?
It's connected, already connected. So very simple. Let's just switch this off again. Okay, so I'm just going to switch it off. So I'll go into what we call config mode, okay?
Okay.
So if I push menu button in and I apply power, and you just hold that for about 10 or 20 seconds, you'll see it comes up with configuration mode. See config mode? Okay, now it's in config.
And it's okay to just pull the power?
Yeah.
Like you pretty much would in the...
Why is it not? Now, typically, as we want to make it work, it doesn't do that. So let me just switch off all of those. Switch off everything. Okay. Let's try this just again. Wait. That's that's me. You can't put the standby unit. That's the co-pilot. That's the pilot. I had the wrong one on when I started the system.
All right, so
let's just do that.
Delete that, start with this. All right, we go into config mode.
Okay, so going into config mode, you just push the menu button in, and then it will come up on config mode. There you go. Okay, and now we can just switch on all the stuff's autopilot and G5. So now you can see that's basically your system setup page. So now for system information, this will tell you exactly what you've got here. So every one of these PFDs, MFDs, it tell you the equipment, it tell you the latest software update version, gives you serial number of the unit, it gives you a complete system here to say what's the communication, is there any breakdowns, what's your version of software. So you see the network error rate, that has to be 0%. So if you've got a 5 or a 10%, that's when you start fault finding, because your CAN bus is the most important thing. It's like imagine a little railway line, 2 lines, and you've got 20 different stations, which means your different pieces of equipment. Yep. Every one of those pieces of equipment is a railway line, and it just parallel hooks onto your CAN bus. So you've got an end and a start point for the CAN bus, and you need to have a termination at each of these ends, which means the furthest is the GMU11. You'll see that we've got a little Garmin CAN terminator in there. Okay, so you've got it at the furthest end, and then this whole thing runs through everything here, and it ends up in the top at the autopilot servo, which is that one there. Okay, on this one I don't have one, but you also have the option of putting a little wire link in, which will tell this thing that is the end stop. Yep. So you tell it there's a beginning station and an end station. If you don't have those things, you're not going to have comms. Yeah. Very, very critical. Okay. So now, so as I say, you can go through these. Now you can literally see, everything is on here. So if it sees it, it's working. See the roll and the pitch servo? So there it says roll servo, pitch servo, GMC. So once it talks to everything, you'll see the GPS is not on, simply because the GPS is not connected to a GPS antenna and things. Okay. ECU is electronic control unit. So now you can go all the way and you can push back there. So you can go back And now you can go to all the system options. It will tell you it's it's certified, non-certified. We can go to the LRUs. It tells you all your equipment, and here you can enable or disable. For example, you see the engine interface. So we use that one. But when you've got two engines, you're going to use 1 and 2. So you can have different things. There's all the different things that you can do there. When you've got your ADAS, there you'll see some red. You see the GPS data. It doesn't get its GPS data yet. And then some of the things still has to be set. Like your GMU 11 must still be calibrated. You go to the magnetometer there, you'll see. It's not calibrated yet, so we still have to do the calibration. And you literally do that exactly as you do the calibration of a compass in an aircraft.
Yep.
15 degrees at a time. So, then you've got your autopilot set up there. You're going to tell it if it's got a roll, if it's got a pitch, servo. All of that, fly director if you have one. Trim, how you've set up your trim, pitch trim. Is it enabled, disabled? In here, you're going to have a bunch of things that you can put your aircraft identifier, everything that's, you get the width of the aircraft, the fuel type. So you can, if you go, for example, there, you can say jet A1 or diesel, so we'll just say have gas. Then there you can go to a low
High
wing.
wing. No, high wing.
Go. Oh, that's going to be
wing.
a high wing, of course. Sorry, man. Where's it? Yeah.
There it is.
Yeah, that looks better.
See, and it doesn't have struts, so it's obviously a Sling high wing.
Yeah, it's a Sling, yeah. And then you can do yourself. And planned cruise speed, it's about 250 knots, of course. But Sling, man, it's fast.
Downhill, right?
Yeah, downhill.
With a tail.
Down a mine shaft. Anyway, so there's a lot of things. Your weight and balance, once we've done the weight and balance, you can enter all the data of your weight and balance into this system here. So when you get into the aircraft, and depending on the loading, you just load it. Passenger, co-pilot, passengers in the back, baggage. And it will
Calculates
tell
it
you
all for
are you
you.
in or outside the envelope. So really very nice and easy to use. And then just here your units, obviously if you're in America or wherever you are, it's going to be nautical miles or knots, or is it going to be numeric degrees? Is it going to be Celsius or Fahrenheit? You can do all of that things there. The display here, you can play with a display. So you can decide also what your display should look like. You can have stripes, or you can have round gauges. So, when I started flying these EFA systems, man, I couldn't get my head around, the stripes. So I had to put round dials on it.
You did the 6-pack, did you?
Yeah. So you use your 6-pack. So you have lots of things to play with. Backlighting is really just how bright the thing will be in daylight. But generally, it's got a sensor there that will always monitor the ambient light. So the ambient light will determine how bright that is. So when you are actually flying at night, it will automatically dim. But you can also set that light if you want. Then sounds, that's, warning, you've got all kinds of warnings and things. You can, you can say what you want, how you want it. You can have volumes and things to go with it. That is really just your RS-232 setup. Now the RS-232 setup is just for communications between the transponder and that unit there. So you have to open up certain ports for, so that things can communicate with each other. And that, obviously you have to wire them accordingly. A-Ring 429, that's a little setup there, and that's mostly for your GPS data. Then PFD and GPS navigation, my best. So everything that's on your audio panel here, you can set it up here to say what you want, how you want it to work. However, you've got a manual audio panel here, which is really as well very nice to use. The COM radio, you just tell it what radios are you using. We do not have a nav radio. We've got the transponder, which is a GNX 375. And then that's just at this point, the software, that's the latest software loaded yesterday. But that's the internal software, not the GPS data. So it doesn't include 3D terrain mapping for Australia. We'll download that later. Data link, I seriously do not actually know what the hell this is. I see some kind of a Mode S address.
I think that's for military concerns.
I don't even know what that is. Seriously. Then you can obviously, when you've got an SD card in there, you can lock your flight. You can lock engine instrumentation. You can actually lock certain details of your flight as well. Engine and airframe. This here is where we will. So we are going to go into each one of these to say, okay, our cylinder head temperature, CHTs, we do not have any, so it's none. But we've got EGTs. So when we go to EGTs and it's connected to the engine, then we will tell it what kind of sensor it must be looking for. So in our case, it's going to look at the Rotex FADEX system. Immediately brings up your gauges. Now you can program the gauge for a minimum, maximum temperatures. You can do markings. You can assign colors for too cold, all good, too hot, or a warning when it gets too hot. So that's really nice. Once you do all of the engine there, RPM, then we're going to go to fuel. And on the fuel, we're going to say it's the left tank, and we will go left resistive. Because Sling supply us with resistive gauges. Now, just a note on that. The normal, it's a very VDO. It's a VDO resistive gauge. That's why I always dip my tanks, and I will not fly a Sling if I don't see fuel, because those resistive gauges are purely an indicator. They are okay.
Yeah.
If you really want top class, get yourself capacitive gauges. There's a company that makes one specifically for Sling. Can't remember the name right now. We've just installed a set for one of our other builders. Actually, yeah, very, very good gauges. They fit into the exact same place. However, it needs voltage supply as well. As where this is a single line to the resistive gauge, your capacitive gauges will need voltage and a sensor. So if you're going to go that route, it's a simple matter of pulling 2 extra power wires into the gauge. Highly recommendable. However, if you fill up your tanks and you've got your fuel totalizer, because this unit will give you the amount of fuel that you've used, it's within 7% correct. I rely 100% rather on my fuel totalizer than on what I see on the gauge. So that's just a note. Okay, but you can, I mean, you've seen there, if you've got capacitive gauges, you're just going to say it's going to be a voltage driven gauge, so or not. Okay, when we just go back, okay, just say cancel. And so that's fuel, and then you can have more than one fuel tank. For example, you'll see, because you're going to have, say GP3 is fuel 3, you're going to have a fuel tank that sits on the firewall, only 5 liters. It's going to be calibrated. It's got a little gauge in there, and that tank it's what they call the header tank. So you're going to have a header tank in there, so we will calibrate that. And then you've got other options too. Obviously, you can have volts to one, you can have shunts. We will fit a shunt. Shunt will tell you how much amps you're using. The volts, we will have 2 volts. One will be your main volts, your main battery. The other one will be the backup battery for your instrumentation. So all of that still has to be calibrated. And then you can have fuel flow and fuel return. So because the Rotex engine has got a full FADEX system, it already measures fuel use. Okay? But say you've got a Rotex 912 engine, you do not know how much fuel goes and comes out, so you can fit only one gauge that shows you the amount of fuel you use, and normally there you'll use something like a red cube. It's a little fuel flow meter, or you can have one for the fuel used and one that's returned to the tanks. That one is obviously, if you've got both, you program both, and you've got a much more accurate use. So you could probably get your fuel to 1%.
Yeah.
Whereas the Rotex one, I would say about 7 to 8% accurate. I've heard various reports, but I've flown a lot now, and I can tell you it's never been worse than about 7-8% according to my calculations. Okay, so it's pretty good. If you really want to fly down to the 10% accuracy level, don't push it that far.
Yeah.
It's just not necessary. Why would you see the gauge is at 10 liters and you, I hope there's still 10 liters, you know? I just don't do it.
No. It's not worth it.
Yeah, and then you've got external lights. What have we got? Flash selection, automatic flashing. So we select the flashing of these. You flash both lights, so you can actually via that unit you can do the GAT29 light flashing and so that's why you'll have external flash. You'll have your standard weak back type thing there. Cockpit lighting. Again, there you can have, that is really more when you go for a LED type lighting. Say for instance your backlight on your panel. So you've got a LED light built into your panel, you know, like the backlights. It's a LED light. So you will need a PWM controller because you can't dim a LED light. It will dim and then it will just start flickering and switch off. But with pulse width modulation, PWM, you can literally dim a LED light. So when you have that kind of panel lights, you will have a little resistor or a little controller. It's a variable resistor, typical, like something like that. Got a little knob, has got a little resistor on the back, and you can adjust the brightness of the light. But remember, it's a LED light, so you need to run the light through your GAT, your light controller, which will then supply a pulse width to your LED light to dim it properly. Okay.
Yeah, do we have those? Or?
Well, you're not going to have backlighting on your panel.
Right, yeah.
No. So, yeah, and then that's just, if you've changed everything, you save and reboot, that will normally just, yes, that will normally just take you back to your original display. You can access some of the functions in flight as well.
Right.
But not all of it. It will not allow you to do anything engine, etc. Will allow you to work on the autopilot. It will allow you to set while you're doing your like the stall warnings, your angle of attack, that kind of thing. So you physically simulate, and it is a whole process. Once we do the flight testing, I will show you in the cockpit. You know, while we do the angle of attack, you have to, it tells you exactly what to do. Start increasing the angle up to the point where it stalls. Then it will take the highest angle, and it will remember that is the highest angle with or without flaps. So there's a lot of different functions: slow flight, fast flight, glide, approaches. So you can do all of that. You set it up. So basically all the color bands on your airspeed indicator, you calibrate in flight, and you've got the access while you're doing that. That's about it.
But you don't ever access the config setup while you're in the air, because you
No,
have to.
99.9% you will never have to go in there. Once it's set, it works.
Right.
Okay.
Fantastic. That's exciting.
That's a bit of a, some of it may be built, hopefully most of it is for truth. Yeah. So you've got your standard map,
Right.
which is mostly shows just the main features. But then you've got charts, like your physical flight charts,
Yeah.
and in Australia you can have all the WAC charts and BNCs and things. So when you have your waypoints, you can put waypoint information. You can do a full flight plan here. So you can use either the external GPS, which is this unit here,
Right.
or you can use the internal GPS, and you can just change it the internal, which means it will use. So that's why we've got two GPS antennas. We've got one WAS certified for this unit,
Right.
and then we also have another GPS antenna for the display, and that just plugs in directly into the back of it. And then weather, we do not have weather data in Australia, unfortunately, but for that,
If you put your Starlink in,
weather or whatever.
yeah, it would.
If you've got your, the terrain, you can see it's crosses because you get obviously vertical terrain, and it will show any highlighted areas in red or green, but we haven't done any downloads yet. And then there you will have your traffic, but there's no downloads or nothing yet. And then that's your satellite information, which obviously all of that still has to be set. Yeah.
Gosh.
Good. So this one going to be sitting somewhere here. This one's going to be sitting here.
Above
so-
or below the vents? Probably.
I'll have to see. I'll really have to just get that little plate again to have a look.
Yeah.
The other option is to possibly put it up here somewhere. I'll just have to see that back panel. But I've got the wiring in for one of those in the back.
Yeah.
But my other query is, do we need one on each side, or do you just need one on the one
I
side?
think we should do one on each side.
I think so.
The more the merrier.
Yeah. And did you say there's one down here and one in the back by the
No, either down there or up there.
either?
Yeah.
Can't do both?
If you want both, yeah, we can. It's just extra. I mean, it's more just pulling extra wires in. It's all it is.
All right. Well, we talked about potential for oxygen concentrators down
Yes.
here.
Yes.
And then,
So there, we need to maybe have a look at a nice panel-mounted 12-volt little connector. Typically, what the guys would do is something like just a cigarette lighter, and they just push the cigarette lighter in there. That's pretty decent for that. And so the idea that you can look at is it's got all this paneling here. So there's space here. So when you have an oxygen concentrator, some of the people just put it here under the seat. But it really needs to be very secure.
yeah.
That's the biggest thing with the oxygen concentrator. So my advice would be, if you do have one or want to carry it, put it in the back behind the seats.
Yep.
It's probably the better place
Be
for it.
safer, yeah.
Get somebody to maybe sew Velcro
Yeah. Case.
loops on it. And if it's in a case, you just stick it onto the carpet.
Right.
So it's not going to go flying anywhere. So yes, maybe we should just look where can we put this extra little one, because you don't want to get in and out and fall over wires and things. So we'll try to get the wires out of
Yeah.
the way.
Well, backseat passengers might want to power their devices.
Yeah. Yeah, of
And we
course.
also talked about putting a Starlink back there, either mounted or.
Very, very important to run a little fridge in the back for the beer when you get there.
Exactly.
You need something cold when you land, mate.
Or to keep Tasha's Costco purchases
I
cold.
always have this thing. If I am done flying, but my wife still want to fly, a little bit further. Once I've had the first beer, she knows we can't fly anywhere anymore, so we stay. Yeah, but no, it's a good idea to have something, but your outlets must be practical. That's why I'm just discussing where we want to put these things.